final was just to correct some XML that wasn't correctly formed, because the dictionary entries are not regular. You can have, for instance, some entries have the etymological origin of the word, some others doesn't have. So the rules try to be generic, and sometimes they generate some XML that is not well formed. So final writing system is just to check. For instance, if I have a closing tag form and the closing tag says, I know that I want just to close the form and I want to close the sense. Okay? So it will rewrite the document step by step, trying to get nearer to the XML document as soon as I can. Okay. In this example, we have a text file for each letter. The total size of the text files were 13 megabytes. Of the XML is 30 megabytes. It's easy to notice how this can get big with XML. But the process takes about 9 minutes, so it's not fast, but at least it was easy to write. Why? Okay, 5 minutes. Why it was easy to write? Because you can start writing who, one who by a time, and you type it and check what is output. Then you write another who to check what is the output. Okay, so you can go step by step trying to get near the output of the output file you want. Okay, but we also notice another thing. That is, XML is text. People don't like to think that, but it is text. Sometimes we don't want to process XML by inserting down tree or using sets. Sometimes we just want to perform substitutions, and here you go. So we can rewrite XML as well. Yes. And especially, why can we write an XML with some easiness? Basically because Perl, especially with 5.10, have some irregular expressions. So you can perform, using regular expressions of Perl, some of that expressions that you are teaching in school that can be written in regular expressions. Okay. For instance, if you want to match A n times B n times, you are teaching in school with mathematical expressions that it is not possible to match, and with Perl can. So, what can we do with regular expressions? Basically, you already know that you can define capture zones. You already know that you can define look ahead and look behind. So you can look, okay, I don't want to match that thing before, but I just want to be sure that it is there. Or more interesting yet is recursive regular expressions that you can define in Perl final tag. This one is copies from the main page. Basically matches balanced parentheses expression. Okay. Basically a list expression. How would this work? Basically you have two parts. One that is parentheses, nothing that is a parenthesis, closing parentheses, or the same thing but with the regular expression inside. This is the reference to the full regular expression. You can read the main page, that is easier to understand than to explain here. My point is not that to explain how this works, but to say that you can define regular expressions, and I'll show you what they are too complex, to match well-structured, well-formed XML fragments. So we defined two classes, XML and XML parentheses, tag parentheses, that matches well-formed XML blocks. Okay? So if I put in my regular expression in my writing system, that XML with a tag name, it will match any block with a tag name. Okay? Can have how much segment it has, can be empty tag or a normal tag. And it does something more interesting, that it puts in the capture variables of $+ name of the tag, contents and attributes, some of the parts of the HTML, so we can process it easily. So, here's another stupid example. There are some kinds of documents, you probably never cross the hand with them, that are named the translation memories. Basically, when a translator does translation, it saves its previous translations in the database, and you can export the database in a standard file format, that is a translation memory exchange format. This file has basically the main structure is a sequence of queue entries. Okay? Each queue entry has a pair, that is the sentence in the original language that you are translating, and sentence in the language you translated to. And my stupid example is I want to remove translation units that are equal. Okay? So, how this was done? Basically, my coding system is one line that matches a queue block, okay, and matches the full queue entry, and I substitute it by nothing if it is duplicated. And the duplicate part, not relevant for the coding system, basically removes all XML strings, so concatenates contents of the file, calculates and identifies that string, and stores in a dash marked it as wisdom. Okay? So if another string equal appears, it will treat it manually. Of course, this is quite simple, because if you have one string with a space and another with a space, you will consider that different, but it is But what is the advantage of using this system? Also, the system also loads the file to memory. Text, okay. Stores the file to memory. The full file in text format takes less space in memory than the full DOM tree. Okay. So it is quite easier to process bigger files with the approach than to use a simple DOM. Of course, you can mix DOM with text and split the sequence by use and another. So, my conclusions with this tracking system is that it is very flexible, because you can write anything you want. It's powerful because you can write zone style, you can create a make the result better. Easy to learn, no expressions, you know how to use it. It goes quickly because you get trained okay, on one tool and it gets better, okay, on one tool. But this is the problem, that is, as it goes quickly, it becomes unmaintainable easily. Okay? Because, especially in the pixel point approach, it is easy to have tools that write some of the parts that are written, so you have to be quite be sure that your algorithm tools that are not matching already text. So which system can be maintained. Fortunately, you can define debug flag where it says okay, apply the tool and obtaining this result, apply the tool. Have a full backtrace of what was done, so you can debug. The virtual regular engine makes this possible, because you don't have